Welcome to the channel Teach Ed. Today is the 6th lecture of the series Electronic Circuits and Devices, and in today's lecture we'll discuss about the difference of JFET and MOSFET. JFET junction field effect transistor and MOSFET metal oxide semiconductor field effect transistor are two types of field effect transistors, which are voltage-controlled devices used for amplification and switching of electrical signals. Here's the physical difference between JFET and MOSFET. The main difference between JFET and MOSFET is in the way the gate controls the current flowing through the channel region. The voltage applied to the gate in JFET modulates the width of the depletion region, while in MOSFET, it creates an electric field that forms a conductive channel. JFETs have a simple structure consisting of a single p-n junction and a channel made of n-type or p-type semiconductor material, while MOSFETs have a more complex structure consisting of a metal gate separated from the channel region by a thin layer of oxide. The gate is formed by a region of opposite doping type, which creates a depletion region that varies the width of the channel and hence the current flowing through it. In case of JFET, while in MOSFET the gate voltage controls the flow of current, by creating an electric field that attracts or repels the charge carriers in the channel region. In JFET, the gate voltage controls the width of the depletion region and therefore the resistance of the channel. While in MOSFET, MOSFETs can be either n-type or p-type, and they offer several advantages over JFETs, including higher gain, faster switching speeds, and lower power consumption. JFETs have high input impedance and low noise but have limited gain and can be affected by temperature changes, while MOSFETs are widely used in digital circuits and power electronics applications. In summary, JFETs are simpler and have higher input impedance, while MOSFETs are more complex but offer higher gain and faster switching speeds. The choice between the two depends on the specific application requirements.